But how we can convert the stoichiometric numbers into grams used in the chemical reaction? If we calculated the formula mass in grams and multiplied it by the relevant stoichiometric number, we can know how much materials we need to use in grams and how much it will be produced. For example, here we have 2 moles of magnesium that burns in presence of 1 mole of oxygen to give us 2 moles of magnesium oxide. If we converted the moles into grams, we will be able to calculate the number of grams that are used and produced. We have 2 moles of magnesium multiplied by the formula mass of magnesium, 24.3, equal to 48.6. And for oxygen, we have 1 mole multiplied by the formula mass of oxygen gas, which is equal to 16 multiplied by 2, because oxygen gas contains 2 oxygen atoms, equal to 32. For the product, we have 2 moles of magnesium oxide multiplied by the magnesium oxide formula mass, which is equal to 24.3 for magnesium and 16 for oxygen, equal to 80.6 grams. You can see that if we burned 48.6 grams of magnesium in presence of 32 grams of oxygen gas, we will form 80.6 grams of magnesium oxide. We call oxygen gas the limiting reagent because it is presented in less amount than magnesium. The limiting reagent is the reactant that is completely used up in a reaction and thus determines when the reaction stops. Usually it is the reactant that is presented in less amount than the other reactants. Let's solve this exercise. 10 tetraoxide is reduced by carbon into 10. Carbon monoxide is also formed. So we have the equation 10 tetraoxide plus carbon to give us 10 plus carbon monoxide. Calculate the mass of carbon that exactly reacts with 14 grams of 10 tetraoxide and give your answer to the 3 significant figures. Knowing that the relative atomic masses for carbon is equal to 12, oxygen equal to 16, 10 equal to 118.7. First step, we will need to calculate the molar mass for each reactant. Notice we will not need to calculate it for the products. The molar mass of 10 tetraoxide is equal to 1 10 atom plus 2 oxygen atoms, 118.7 for 10 plus 2 multiplied by 16 for oxygen equal to 150.7 grams. The second reactant is carbon. The molar mass for carbon is equal to 2 moles multiplied by the molar mass of carbon 12 equal to 24 grams. The second step is to calculate the number of moles for 10 tetraoxide by dividing the given quantity, 14 grams, by the molar mass, 150.7, which is equal to 0.0229 moles. Notice 1 mole of 10 tetraoxide reacts with 2 moles of carbon. By that, the mass of carbon in grams is equal to the number of moles we obtained in the previous step multiplied by the molar mass we calculated for carbon, which is equal to 2.22959 grams. Let's round it for 3 significant numbers is equal to 2.23 grams. We can calculate the mass of the reacting carbons in just one step as well, which will minimize the possibility for error. So, the mass of carbon in grams is equal to the given quantity, 14 grams, multiplied by 1 mole for 10 oxide, contains 150.7 grams for 10 tetraoxide, multiplied by 2 moles of carbon, react with 1 mole of 10 tetraoxide, multiplied by 12 grams of carbon, found in 1 mole of carbon equal to 2.229595, and we round it to the 3 significant numbers equal to 2.23 grams. We said we can know the amount of one of the reactants or one of the products if we know the amount of one of the reactants and the products. In turn, we can find the stoichiometry for a reaction if we know the exact amount of all reactants and the products. For example, if we know that 4 grams of hydrogen reacts with a number of grams of oxygen to give 36 grams of water, and we know that the relative atomic mass of the hydrogen equal to 1 and the relative atomic mass of oxygen equal to 16. We said before the number of moles, capital M, equal to the mass in grams, small m, divided by the molar mass, N. For hydrogen, 4 grams divided by the relative molar mass of hydrogen gas, 2 by 1 equal to 2 moles. Now let's calculate it for oxygen. Although we don't know the grams of oxygen reacted with hydrogen, we can deduce it. But first, we need to write a balanced chemical equation. We write 2 before the hydrogen gas because we calculated in the previous step that 4 grams of hydrogen gas are equivalent to 2 moles. And at the product side, we need to write 2 before the water molecule because on this side we have 2 by 2 4 hydrogen atoms. So we need here 2 to have 4 hydrogen atoms as well. If you look at the product side, it has 2 oxygen atoms, and here we have 2 as well. By that we know that 2 moles of hydrogen gas reacted with 1 mole of oxygen gas. And from that we can even calculate the oxygen in grams reacted with hydrogen. 1 mole of oxygen gas, O2, is equal to 16 by 2, equal to 32 grams. By that, we were able to deduce that for every 4 grams of hydrogen, we need 32 grams of oxygen gas to react. If we looked at the product side, we know that 36 grams of water were produced. Therefore, the number of moles is equal to 36 grams of water divided by the molar mass of water, 2 hydrogens multiplied by 1 relative mass plus 16 relative mass of oxygen equal to 2 moles.